questions 21 through 25 on the 2006 grade 12 AMC 12B. Rectangle ABCD has an area of 2006. An ellipse with area 2006 pi passes through A and C and has foci at B and D. What is the perimeter of the rectangle? The area of an ellipse is pi AB, where 2A and 2B are the lengths of its axes. So first let's draw a diagram. So here is the ellipse with the rectangle drawn in, and a few things I of course have to label. The length and width of the rectangle I'll just call W and L for length and width. The foci, of course, as they say in the question, are located at B and D. So the distance from here to here is going to be C, and the distance from here to here will also be C. And we know that 2A is the distance all the way across the axes like that. So from here to here, for example, is A. And this whole distance is 2B, so the distance from here to here is B. And a few fundamental properties of ellipses. The first is, for the foci, c squared is equal to a squared minus b squared. For all ellipse, that is true. Another property of an ellipse is that if you have a length and a width drawn the way we have drawn it, it will equal to 2 times a. And they tell us in the question that a rectangle has an area of 2006. So the length times width is 2006. That's given in the question. And then also given in the question is that the area of the ellipse is 2006 pi, and we are told that you figure out the area of an ellipse by multiplying pi times a times b. That's also given in the question. So this just simplifies to 2006 is equal to AB. Okay? All right, so now let's look at the diagonal BD. From here to here, that diagonal BD we have labeled as being equal to 2C. And we know from this formula here that c squared is equal to a squared plus b squared, and therefore c squared, if you were to take the square root of both sides, would become just the square root of a squared minus b squared. And if you multiply both sides by 2, you get 2c is equal to 2 times the square root of a squared minus b squared. All right? So those are just some of the things that we need to set up in this question before we solve for it. Remember, we're trying to solve for the perimeter. So we want to eventually find the perimeter, which is of course equal to 2 times the length plus the width. Now, first let's look at this triangle right here, and that is of course giving us a Pythagorean relationship that L squared plus W squared is equal to 2C squared, entirely because of the Pythagorean theorem. So this means that L squared plus W squared is equal to this all squared, because that's equivalent to 2C. So 2 times a squared minus b squared all squared, and that is equal to 4a squared minus b squared, like that. All right, and then the next equation that will be beneficial to us is this one right here. I'll circle it. L plus W is equal to 2a. These two equations will help us solve for L and W, and in particular, what we are really looking for is the perimeter. So there we go. Now, before I get into the calculation, I want to remind you of a few things. L plus W squared minus L squared plus W squared. Now, it might seem a bit strange to write it like this, but watch what happens. L squared plus 2LW plus W squared minus L squared minus W squared. And this just simplifies to 2LW. This we know, and this we know. So if we can put it together, we can just get LW. And what's the significance of LW? Well, that is the area. And LW, we know, is 2006. So it's all going to come together for us. So let's do that. We've got L plus W squared minus L squared plus W squared, like that. And that is equal to 2LW. Exactly what I did up there. And then if we continue with this by substituting, L plus W is 2A. So that'll be 2A all squared, minus L squared plus W squared, and that is 4A squared minus 4B squared from up here. And that is equal to 2 times LW. But LW, we know, is 2006. Remember, we were given that actually in the question. So this looks like, if we expand this, becomes 4A squared minus 4A squared plus 4B squared is equal to 4012. The 4A squareds both cancel, and then B squared will become 1003, and therefore B is equal to 1003 under the square root sign. And now we want to figure out what is A, and we can do that because we have this formula right here. This was also given to us, 2006 equals AB. So that will help us solve for A. 2006 is equal to AB. That means A is equal to 2006 over B, and B is 1003 square root. And then now finally we can figure out the perimeter. The perimeter, if we use the basic definition, is 2 times L plus W, like that. And L plus W, we know, is equal to 2A. So that's 2 times 2A. So that's 4A. And then A, we just figured out over here. So plug that in, 2006 over square root of 1003. And then we multiply top and bottom by 1003 to rationalize the denominator. And this will give me, let's see here, this becomes 1003 on the denominator side. So 2006 divided by 1003 is just 2. And that's times the square root of 1003. And that is 8 times the root of 1003. And that is the perimeter of that rectangle. So that would be choice C. Suppose that A, B, C are positive integers with A plus B plus C equal to 2006. And A factorial times B factorial times C factorial is equal to M times 10 to the power of n, where m and n are integers and m is not divisible by 10. What is the smallest possible value of n? 8 factorial times b factorial times c factorial is equal to m times 10 to the power of n. And we can further break down 10 into 2 to the power of n times 5 to the power of n, like that. And now this becomes a question that is essentially telling us to find factors of 5. And if we can do that, we can figure out what is the smallest possible value of n. And the way you do that is you take each of these numbers and you divide by the total number of factors of 5. So for example, if a number is, say, 10, 10 is divisible by 5, right? That will give me 2 factors. And in a very similar way, we have to do that for all of A, B, and C. But we don't know the values of A, B, or C. So the only thing we're told is that A plus B plus C equals 2006. Okay. Well, I want the smallest possible value of n. So what I'm going to do is choose numbers that are very close to each other. 668, 669, and 669 for A, B, and C. And if I did that, the sum would be equal to 2006. Now, this seems like a right choice at first, but the problem is that this is not going to give you the smallest possible value for n. Because one important thing to notice is that 5 to the power of 4 is 625. And each of these numbers has 625 as part of it when you do a factorial. So if I can choose a number less than 625, it will give me less factors of 5. So for example, if I chose 624 for 2 of them and then put the remaining amount into the third one, making C 758. This strategy will make me get the smallest possible value of n. Alright, so how do I get the smallest possible value of n? How do I calculate the number of factors? Number of factors is using this equation. You take the number and you first divide by 5. And you get an integer value. That's what that symbol means. Then you add to it a divided by 25. That's also going to give you the number of factors. And then you just keep going like this. A divided by 125, which is 5 to the power of 3, basically. And so on. A over 625. And ongoing like that. Okay? And you have to do that for both A, for B, and then also for C. And then add them all up. So let's do that for our values. So we've got 624 over 5, the integer value, 624 over 25, the integer value, 624 over 125, the integer value, and then 624 over 625 is not necessary because, well, first of all, it won't give you an integer that's 1 or above, but also because 624 does not divide by 625. So we're done here with A. Now with B, well, B is the same number, so it's pretty much the exact same thing. 624 divided by 25, like that. 624 divided by 125. And then for C, of course, we're probably going to have to do a little bit more work. 758 divided by 5, the integer value. 758 divided by 25. 758 divided by 125. And we also have to do 758 divided by 625, because this is going to give me at least 1. And this is going to be my answer. So doing the math, I get 124 plus 24 plus 4. And then I get identical 124 plus 24 plus 4. And the 758s, they give me numbers 151 plus 30 plus 6 plus 1. And if you add this all up, this is 152 plus 152 plus 188. And that is equal to 492. So 492 is the answer to number 22, and that is B. Isosceles triangle ABC has a right angle at C. Point P is inside ABC, such that PA is 11, PB is 7, and PC is 6. Legs AC and BC have length S equal to the square root of A plus B root 2, where A and B are positive integers. What is A plus B? So let's label as much as we can. A lot of this they've already labeled for us, But BC, they tell us, is S, and CA is also S. It's an isosceles triangle. And they also tell you that it's a right angle right there. So I'm going to call this angle in here theta, and this angle will be therefore 90 minus theta. Okay, and now I'm going to use the law of cosines twice. The first is in the triangle BCP, right here, and the next one is going to be in triangle ACP. So twice I will use the law of cosines, and hopefully when I do, this will make a lot of sense. So here we go, BCP, using this angle. So that would be, for me, 7 squared is equal to 6 squared plus s squared minus 2 times 6 times s cos theta. Okay? And this simplifies to 49 is equal to 36 plus s squared minus 12s cos theta. And isolating for cos theta, it will be cos theta is equal to s squared minus 13 all over 12s. All right? So that's the first one. Now in triangle ACP, in a very similar way, we are going to use the law of cosines. And that gives me 11 squared is equal to 6 squared plus 5 squared minus 2 times 6 times 5 cos 90 minus theta. So this is 121 is equal to 36 plus s squared minus 12s cos 90 minus theta. But 90 minus theta, I don't need to put that in there. I can just put sine of theta. Make that substitution. And then if you isolate for sine theta, you will get s squared minus 85 all over 12s. So there you go. That's the first part of the question. So we've got two very important relationships here. Now I hope you remember that sine theta squared plus cos theta squared is equal to 1. So that is the relationship or fundamental principle that we have to use. Cos theta we know, sine theta we know, at least in terms of s, so let's substitute them in. So I've got s squared minus 85 all over 12s all squared plus s squared minus 13 over 12s all squared is equal to 1. And this is the formula that we will hopefully be able to get some sort of value for s. Okay, we got a lot of algebra ahead of us, so here we go. S to the power of 4 minus 170 s squared plus 85 squared, which is 7225. And then that's going to be all over 144 s squared. And this one is s to the power of 4 minus 26 s squared plus 169. And again, that is over 144 s squared. And that's all equal to 1. All right, let's see if we can collect like terms here. 2s to the power of 4 minus 196s to the power of 2 and plus 7394. And we can put the denominator on the other side like this, 144s squared like that. And then putting everything on one side, this will be 2s to the power of 4 minus 340s squared plus 7394. And I think I can divide through by 2 to give me s squared minus 170 s squared, s to the 4th, plus 3697. And there you go. All right. Now we've got to use a quadratic, s squared this time, minus b, so we got minus 170, plus or minus square root of b squared, so minus 170 squared, minus 4ac, 3697, like that, all over 2a. So this becomes 170 plus or minus 28900 minus 14788, and this is divided by 2. 170 plus or minus 14112 all over 2, and this is 170 plus or minus 84 root 2 all over 2, and this gives me 85 plus or minus 42 root 2, like that, and that is s squared. Okay. All right, but in the beginning of the question, they told us that s was equal to a plus b root 2, all under the square root sign. So therefore, s squared is going to be a plus b root 2. And that is 85 plus 42 root 2, if you take the plus part of that. And matching coefficients, that means that a is 85 and b is 42. So they want you to find a plus b, and that is of course 85 plus 42, which is equal to 127. So the answer to number 23 is E. Let S be the set of all points x, y in the coordinate plane such that x is between 0 and pi over 2 and y is between 0 and pi over 2. What is the area of the subset of S for which sine x squared minus sine x times sine y plus sine y squared is less than or equal to 3 over 4? So we've got sine x all squared minus sine x sine y plus the sine of y all squared is less than or equal to 3 over 4. So the first thing we need to do is solve for the equation when it's equal to. So what that really means is the following: sine x squared minus sine x times sine y plus the sine of y all squared minus 3 over 4 is equal to 0. I've set it equal instead of less than. Less than we'll worry about later. First we need to solve this. Okay, this will basically be like a quadratic of the form ax squared plus bx plus c equals 0. So I can use a quadratic equation, quadratic formula, solving for sine x. So minus b, so minus sine y, plus or minus the square root of minus sine y squared minus 4ac, and c is sine y all squared minus 3 over 4, like that, all over 2a. Okay, so here we go. This becomes sine of y plus or minus. Under the square root sign, we've got sine of y all squared minus 4 times the sine of y squared plus 3 all over 2. So this simplifies further. Sine y plus or minus 3 minus 3 sine of y squared under the square root all over 2. Now at this point, I'll put on the side here something that I hope you remember. That is that the sine of x all squared plus cos of x all squared is equal to 1. Correct? So that means that if you were to isolate for just cos x all squared, it's 1 minus sine of x squared. And we have something very similar to that underneath the bracket. We have 3 times 1 minus sine x squared. So that is just 3 cos y all squared under the square root sign, all over 2. All right, so we're simplifying here. And let's not forget what this is, sine x. Sine y plus or minus, well, the square roots will disappear, and this just becomes root 3 cos y, all over 2. And at this point, you have to recognize that this is going to be now 1/2 times the sine of y. Okay? Or what I'll do is I'll write it in the exact format that I want you to understand. Sine of y times 1/2 plus or minus cos of y times root 3 over 2. Now at this point, we will use another trigonometry rule, and that rule is as follows. If you have the sine of x plus y, that is equal to the sine of x times the cos of y plus the cos of x times the sine of y. And in this one, this right here, we just leave alone, but this is the same as the cos of pi over 3. This we leave alone, but this is the same as the sine of pi over 3. So using this formula, we can now conclude that the sine of x is equal to, pay attention now, this is sine of y plus or minus pi over 3. Okay, using this formula right here. So, since the sine of x is equal to the sine of y plus or minus 3, get rid of the signs, and that means x is equal to y plus or minus pi over 3. So this gives me a couple equations, right? It gives me first equation, which is x is equal to y plus pi over 3. Isolating for y is equal to x minus pi over 3. This is my first equation. The other equation I get, of course, from here is that x is equal to y minus pi over 3. And isolating for y, you get y is equal to x plus pi over 3. Like that. And there's one more equation that this will give us that will help us tremendously in terms of giving us a boundary. And that is that y, or rather x, is equal to pi minus y plus pi over 3. Like that. Because if x is equal to y plus pi over 3, and you take the sine of it up here, if you subtract that from pi, and then you take the sine of it, it will result in the same value. So this is also an equation that you can create. Now what we have to do is we have to plot these three, and that will help us figure out what they want in the question, which is an area. So here's the graph, and here's our boundaries, pi over 2 to 0 for both the x-axis and the y-axis. Those are the boundaries given in the question. So we can't get anything bigger than this. We can only go in between those two, like this. So these are our boundaries right there, that box, I guess, that square. And then we have to now plot these lines that we got. The first one I will draw right here, approximately. That's this guy right here. Y is equal to x plus pi over 3. Then the next one I will draw, it's going to be something like this approximately. And that one is the equation of y is equal to x minus pi over 3, like that. And then finally we're going to draw this one. And that one will basically be across like this from here to here. And that is representing that equation. So now our area is really what's in this region right here. That is the area we need to figure out. Okay, that shouldn't be that hard. So our area looks like the area of the whole square, which looks like pi over 2 squared. And then we'll subtract from it this triangle right here. And that looks like 1/2 base times height, which is pi over 6 times pi over 6. And then we'll subtract this one here, which is identical. So again, minus 1/2 pi over 6 times pi over 6, 1/2 base times height. And then finally we have to subtract this big triangle right there. And that one is going to be minus 1/2 pi over 3 times pi over 3. Okay, so this becomes pi squared over 4, and this looks like minus pi squared over 36 minus pi squared over 18. So if we get a common denominator, that looks like 36, so top and bottom will be 9, so 9 pi squared minus pi squared minus 2 pi squared. So that looks like 6 pi squared over 36, and that is pi squared over 6. So that means the answer to number 24 is pi squared over 6, which is choice C. A sequence a1, a2, ... of non-negative integers is defined by the rule an plus 1 equals an plus 1 minus an, the absolute value of that, for n greater than 1. If a1 equals 999 and a2 is less than 999 and a to the 2006 is equal to 1, how many different values of a2 are possible? So we can use a table format and figure out A1, A2, A3, A4, and so on, and see what this behaves like. And I'll just do it up until A9, A10, and then of course we can extrapolate that all the way down to A to the 2006. Okay? Now we are told that a to the 1 is fixed as 999. Okay? And let's use our relationship here that an plus 2 is equal to the absolute value of an plus 1 minus an. So we've got an plus 2 is equal to the absolute value of n plus 1 minus a to the n. All right, so here we go. I have to start somewhere, right, with a2. They're saying that a2 is less than 999. So I'll start with 1. Okay? And if that's the case, and I start using this rule, let's see what happens. 1 minus 999 is negative 998, but I have to take the absolute value, so 998. Then 998 minus 1, 997. 997 minus 998, which is negative 1, absolute value gives me 1. Continuing this, we get 996, 995, 1, and then continuing in the same format, we'll get 994, 993, and then just keeps on going, dot, dot, dot. But we are told that A2006 is equal to 1. Now, does this match? Well, I noticed that the ones are kind of repeating, right? A2, A5, A8, and so on. So it looks like if my A has 1 less than a multiple of 3, it will be 1. So for example, A5, 5 plus 1 is 6, and 6 is a multiple of 3. A8, 8 plus 1 is 9, and 9 is a multiple of 3. So if 2006 plus 1 is a multiple of 3, this will work. And it is. So this checks out. And in a very similar way, you can make a table. And when they do, I'll leave that to you to make this big long table. When they do make this table, they conclude that A2 must be odd, the value of A2. The other thing they conclude is that A2 can't be a divisor of 999. Okay, well, first of all, from 1 to 199 inclusive, 999 inclusive, I should say, how many odd integers are there? Well, 499 odd integers. And then we have to eliminate from this 499 all the multiples of 999. Well, 999 is equal to 3 to the power of 3 times 37. 9 times 37. 27 times 37. So that means we have to get rid of all the multiples of 3. We also have to get rid of all the multiples of 37. Those are the prime factors. And we also have to take in the fact that when we take away all the multiples of 3 and 37, we will have taken away multiples of 3 times 37 twice. So we have to add those back. So how many multiples of 3 do we have between this 499 odd integers? Well, we got 166 of them. How many multiples of 37? There's 13. And then this double counts multiples of 3 times 37. And there's 4 of those guys. So our grand total for the total possible values of A2 will be 499 minus the 166 minus the 13, and then add back 4 because we subtracted those twice when we subtract 166 and 13, so we've got to add 1 set back. And if you do this, this becomes 324. And that would make this number 25 answer choice B. And just for the sake of completion, I'm including the official solution to this very difficult problem here. So read this, discuss it with your fellow math contest competitors, and I hope that you will be able to get a complete understanding of this number 25.